Good morning, everyone. Welcome all to another edition of Finzics. I am Mr. Finn, talking about Ohm's Law today. Ohm's Law. This is for Friday, March 20th, 2020. I hope everybody is good. Had a little Google Meet over the last couple of chances with my classes, and so hope you guys are doing well there. Real quick, shout out to one of our a viewer, Dylan Eco1. I don't know who this guy is, but thanks, Dylan, for your support viewing the video cast. This is actually just an opportunity for me to interact with my students who I'm missing because school is closed. But I do appreciate you checking in and commenting. I really do. So thanks so much for that. All right, to kind of go over, retweet, iterate some of our earlier scheduling issues. So for Friday going forward, this is the 4th hour. Google Meet will be at 1 p.m. today. The Monday time, March 23rd, that will be 5th hour at 9 a.m. 6th hour, I don't have a 6th hour. Tuesday at 9 a.m., 0 hour. So 1 p.m., 7th hour, I don't have a 7th hour. And then Wednesday of next week, that's March 25th, I'll do first hour again at 9 a.m., second hour at 1 p.m. Thursday, March 26th, 9 a.m. is third hour, 1 p.m. fourth hour, and then on 27th, 9 a.m. will be fifth hour again. So I'll have that up on the Google Doc for you guys just to make sure you can all get that. Recapping from yesterday, resistance, the piece of resistance, the piece of resistance. Obviously, we know this is a conductor because it's got metal in it and it takes charge from one end to the other. But it's also a resistant piece. So everything in a circuit will have resistance. So the batteries have their own resistance from cell to cell, from the positive terminal to the negative terminal. A meter, like an ammeter or a voltmeter, will also have resistance. Depending on how much that is, it can be very, very small, but everything has resistance to flow of the electron energy. So our question of the day, how can we predict or how can we know about the flow in any circuit? That's a great question. How can we know about the flow in any circuit? And the answer is Ohm's law. Ohm's law helps us predict the flow in any circuit. So what is Ohm's law? Ohm's law is V, voltage, equals current times resistance. So kind of like the F equals ma of Newton's second law, V equals I times R, where current, I in amps, times resistance, R in ohms. I'll show you a couple of examples of that, and then I've got a little lab set up here for us to show you with the same things we have in the diagram. So maybe what I'll do is I'll show you the demonstration first and then go to the magic whiteboard. So let me show you the demonstration first. Okay guys, so what we have here is we've got a battery pack. There are 3 batteries, so that's 4.5 volts. And then this red wire is connected to one terminal, that's the negative terminal, and it goes through this positive terminal here, this positive wire, goes to an ammeter, and you can see here we're reading 0 amps on the ammeter because nothing's plugged in, because the other end is not touching the battery pack at this moment. When we hook on the battery pack, we have one bulb in the system. See the little light bulb lights up, and just like yesterday, we have 0.22 amps, or 0.219. That's kind of fluctuating, but mostly somewhere around 0.21 amps going through the system, and the light bulb will light. So, what happens if we take out a battery? Okay, so we're going from 4.5 volts because each of these batteries reads 1.5 volts. Right there, 1.5 volts. So if I put this battery on the side and I plug this back in over here to this side, well now I'm reading 0.147 or 0.15 amps on my meter. So if you read that, 0.15 amps. So what that means is 0.15 amps are flowing through. And you can notice that the light bulb isn't even on at this point, but there's still current flowing through the system. So there's electron energy going through the system, but not enough to light the bulb. But we still have Ohm's law, because what we did was we took our voltage down, and so lesser flow goes through the circuit because it's the same amount of resistance. So if you reduce your voltage value, you'll have less resistance. Now let's take one more look at this. If I take another bulb, let's take a second bulb, and let's put that right into the system. So I'm just going to disconnect this one, hook it on here. I'm going to put these bulbs side by side, and I'm going to hook this back up to the meter line. Okay, now I'm going to hook this back up to my voltage supply where I have 4.5 volts. If I hook it back on, so now you can see that we're reading about 0.19 amps, or looks like we're settling about 0.16 or somewhere around that value, about 0.165, which means that there is current going through the system, and you can barely see that these light bulbs are lit. You can barely see them. It's just a little bit of energy. So this 4.5 volts now is passing through much bigger resistance with 2 bulbs in action. Okay, now if we real quick, I'm going to just replace them with other bulbs. Okay, so what I've done here is I've replaced the round bulbs with the long bulbs. You can see that the long ones. And you can see it's a little bit brighter now. But we're only reading 0.05 amps. So it looks like these bulbs might have a different resistance than the one before. In fact, a little bit more resistance, interestingly enough. So with the 4.5 volts here and about 0.05 amps, from those numbers, I can determine the resistance of these 2 bulbs together using Ohm's law. And I'll go to the magic whiteboard to show you that. Okay, guys. So if we look at this relationship on our magic whiteboard here, we got V equals IR. That's another way of saying Ohm's law with symbols, kind of like F equals MA for Newton's second law. Okay, volts is the unit of voltage, amps is the unit of current, and ohms is the unit of resistance. Now, yesterday, I did the video on the piece of resistance, piece de resistance. Well, that's R was rho times L over A. Yeah, rho times L over A. What's rho? Rho is resistivity. That's actually a constant. And then we have L over A. So that's length over area. All right. Now, I've got this example here where I've got 3 volts and I've got a 1 ohm resistor. 3 volts and a 1 ohm resistor. So what does that do? Well, using Ohm's law, I equals V over R. So 3 volts over 1 ohm will give you 3 amps. 3 volts over 1 ohm gives you 3 amps. So using that, I know the current in this particular circuit with 1 bulb is 3 amps. What if we change the resistance? Well, now, if I've got 3 volts and the 2 ohms, but they're 2 different bulbs, we call this a series circuit. I'm going to come back to that in later videos next week. But that means that I would be a function of 3 volts divided by 2 ohms to give you 1.5 amps. Because now you have 2 bulbs. So the current should go down, and that's what we saw with our demonstration. Lastly, if we took the 3 volts that we have, and we just divide by 1 bulb, but the bulb is a much bigger resistance. Well, what happens then? I is 3 volts divided by 3 ohms, which is 1 amp. So now we've got 1 amp, 1.5 amps, and 3 amps. Now you might be asking yourself, Mr. Finn, why did it look brighter with the long bulbs than with the round bulbs when it looked like there were less current going through the long bulbs? This is a question we're going to have to tackle on Monday, and it has something to do with power. Power is an indication of brightness. We'll cover that Monday. Okay, guys, so wrapping up, Ohm's law is a relationship between current, voltage, and resistance. Oh, I'm struggling with my, there we go. So tomorrow, or sorry, Monday, I will introduce you guys to another way of looking at this, which is about power, and that has to do with a couple of different variables. My friend here, Nick Leprechaun, French Leprechaun, he'll help us out then. I don't know, this is in honor of Tyler here. This is actually a golf head cover, but I don't have a funky hat for today, so I'm going to use my Irish Leprechaun to help me out with Monday's lesson. But anyway, if you guys got questions, please send them in. Hope that's okay with Ohm's Law today. Have a great weekend, and we'll see you guys back on Monday. Don't forget about those Google Meet sessions. If you have questions, you can either send them in by email or you can get into the Google Meet, and we'll tackle them there. You guys have a great day, and we'll see you then.